How's it going, guys? So I'm going to go over the second assessment review, which looks like this. This is at the top of the front page of it, and it is your homework that you should be using as a, I guess, study guide for your assessment that you're going to take on Monday. Alright, so part one, when you read it, they've given you a formula, right, that calculates the perimeter of a rectangle in terms of its length and width. And then we've got down here three different variables that they want us to solve for, right? So the first thing I would do if I were you personally is I would write down the equation in each of these just so you know what you're working from. And after you do that, you're ready to go. Okay, so in this first one they want us to solve for perimeter, and they're using the variable p. So you locate the p, which is right here, and think what is near it that you want to get rid of, which is this 3. Now what operation is there? We know that there's multiplication hiding in there. So to get rid of that times 3, all you have to do is divide by 3, which is the opposite. I don't know what I just did. These 3's cancel out, and you're left with p equals 6L plus 6W, and that's all over 3. Okay? If you leave it like that, that's fine. You can go further and do like 6 divided by 3 and get your 2L, but if you have this on your test, it's going to be okay. Alright, next one, we're solving for L. What's near the L? Well, we know we have this times 6, but to get rid of that, we'd have to divide by 6. But you see how that traps that 6W in there? We don't want to do that. We want to make it as easy as possible, right? So how do we get rid of a plus 6W? You do the opposite, which is subtract 6W. And I have to do that to both sides of the equal sign. These cancel out. I know I cannot combine 3P and 6W. They're two different things. So it's 3P minus 6W equals, all you have left over here is 6L. And we already said that there's multiplication here. So to get rid of that, we would do the opposite, which is divide. These two 6's cancel out. And what you're left with is 3P minus 6W divided by 6 equals L. Okay? Alright, last one. We're solving for W. So you kind of do the same steps as this one. But you're solving for a different variable. So we know we can't divide by 6 because, as we just said, it traps the other thing in there. So let's get rid of this 6L. You do that by subtracting by 6L. These cancel out. You can't combine these two things because they have two different variables, so you'll just write it out. 3P minus 6L equals 6W, right? Since there's multiplication here, we're going to divide by 6 to get rid of it. And what you're left with on this side is 3P minus 6L, all divided by 6, equals W. As I said, some of you guys like to simplify it down further and divide this 6 out into the numbers above it, but if you have that, that's fine. Okay? Moving on to the word problem, part 2. It says Michael, John, and Adam have many Xbox games. Adam has 4 times the amount that John has. Michael has 15 more games than... Oh, that's a typo. That should say John. So Michael has 15 more games than John has. And together the three boys have 75 Xbox games. How many games do Michael, Adam, and John have separately? So, talking about a few people here. We've got Michael, John, and Adam, right? So the way we've been doing it before in class is we're thinking about the one person that they haven't given us any information on. They told us about Adam, right? They told us about Michael, But they haven't told us anything about John. They keep comparing the other guys to John. So John's going to be our variable for this problem, which is just J, right? So now let's start with Adam, since he's the first one they talk about in the problem. Adam has 4 times the amount of games that John has. So to represent Adam, it would be 4 times what John has, which would be J, because we already said J is what John has, right? And then Michael has 15. He's the next guy. Michael has 15 more games than John. So 15 more would be addition games than John, right? And the 3 of these guys together should have 75 Xbox games. Alright, so let's set this up. So when you're rewriting this, you should be thinking in your head, Michael and John, right, J, and Adam all had 75 games. Okay. Before you even start solving it, let's see some things that look alike here. We've got a few J's, right? Be careful. I know a lot of you guys like to jump to it and just say, oh, there are 3 J's over there. But there are not. There's more than that. So let's go over it. We have 1J. This is 1J. And this is 4 J's. So if you add all your J's up, 1 plus 1 gives you 2 J's, plus 4 gives you 6 J's. So we still have that 15 left. We haven't done anything with that. It's just a number. That's why we can't combine it with our variable, the J. Alright? Now, to get rid of this 15, you would subtract by 15. You don't want to divide by 6 yet, because once again, it would trap that 15 in there. So subtract by 15 on both sides. These cancel out. Bring down this 6J equals 75 minus 15 will give you 60. There's multiplication here, so to get rid of that 6 you would divide by only the 6, and this will give you J equals 10. Now let me reread the problem to make sure I'm done. How many games do Michael, Adam, and John have separately? Okay, I'm not done. I have found out how many games John has, right? Michael has 15 plus what John has. So you could almost take this J away and put in what John had, which is a 10. So Michael would have had 25 games. Now for Adam, 4 times J, I'll just do it right under it. Adam's going to have 4 times what John had, which would be 4 times 10. And Adam has 40. So that's it for the word problem. Hopefully that all makes sense, right? It's a football player. Alright, next. Use your properties of equalities and create a 2-step or multi-step equation with the given conditions. So this is that stuff that we were talking about in class where you're building an equation. So you can literally do anything you want, any property to both sides, and you're building an equation. So I'm just gonna, I like multiplying first, that's just me. I'm going to pick the number 6. So I'm going to multiply by 6 on both sides. 6 times b, even though that looks like a b. 6 times b will give you 6b equals 3 times 6 will give you 18. Alright, now this is just a one-step equation because I've done one thing to it. So let me do something else. Let me add 3 to both sides. I can't combine this 3 and the 6b because they're not the same thing. They're not like terms. So you just rewrite this side, and then you can simplify this side. 18 plus 3 is 21. So that's it. This is a two-step equation that would work for b equals 3. And you could check if you built it right, if you created it right by solving this. You know, you don't have to, but you could subtract. If you subtracted by 3 on both sides, right? You'd go back to 6b equals 18, divide both sides by 6, and b equals 3. So you don't have to do that, but if you're a little unsure on how to build these, you can go back after you build your equation and try solving it for your variable. Anyways, alright, moving on to the next one. This is something that has an infinite number of solutions. We've been talking about it as always, sometimes, or never true. Something that has an infinite number of solutions is an equation that is always true. So we have been starting off with x equals x. We know that's always going to be true because it's literally the same thing on both sides, right? And then just like we built it for this equation over here, we do the same thing here. So I'm going to multiply by, I'll pick 5 this time. 5 times x equals 5x. Doesn't matter if it's x times 5, it's still going to become 5x. And let me add something to both sides. I'll add a 4 this time. Oh, sorry. Okay. Oh my god. It's not getting any better. Alright. You can't combine these because this is just a number and this is a variable. So you would literally just have 4 plus 5x equals 5x plus 4. It's the exact same thing on both sides. Alright? So that's how you build that one. And last but not least, we've got to hit these puppies out. Alright, so this one we've kind of explained. I'm going to show you 2 ways to do this one. 2 ways. Kind of like 2 chains, except cooler, because it's algebra. Oops. No, what'd I do? Is it still recording? Oh my god. Alright, so you have to think, can you put a number in for this x that will make both sides true? And you should be able to determine that if you put in a 12, let's say if you say x equals 12 for this problem, you could determine that 12 over 12 does equal 12 over 12, right? So that's one way it works. Now, what if it was x equals 3? If you plug that in, both sides will not be equal, right? 3 divided by 12 is not the same thing as 12 divided by 3. 12 divided by 3 will give you 4, and 3 divided by 12 gives you some funky decimal, right? So you can determine that this one, this scenario, is sometimes true. Because right here, you're able to show me one way that it worked and one way that it didn't work, right? Okay. And if you don't want to see this, try to skip ahead maybe by, I'd say, 45 seconds, and I'll start doing this problem. But I want to show you the other way to do this. Okay. So let's say you want to solve this equation, right? And we haven't done this too much, but this is like if you want to push yourself with math, right? We're going to get more into it though. How do you get rid of this x down here? Well, there's a division sign. So to get rid of a divided by x, you would do times x. So what you do to one side, you have to do to the other. These two x's cancel out, right? Now these two, x times x, that's going to become x squared divided by 12 equals 12. Now we have this divided by 12. We want to have our x's on one side and numbers on another. So to get rid of a divided by 12, you would multiply by 12 on both sides. And these two cancel out, right? So all you have left on this left side is x squared equals 144. Because that's what 12 times 12 is. Now, just like we've always been doing the opposite to get rid of something, like if we see division, we do multiplication. If there is addition, we would do subtraction. If something is squared, you would take the square root of it to get rid of it. So the square root of x squared is literally, you have to think what times what would equal x squared. And that's x. And then what times what would equal 144? Or even if you have a calculator, you could do the square root of 144. That'll give you 12. And that's one way that you could prove it sometimes. Because we said when you're solving it, if you end up with x equals something, you automatically know it sometimes. So either way, there's two ways you could do this way. Two ways! Okay, next one. So this is the last problem, guys. Automatically I see this 4 outside. We know how you have to do the distributive property. Whee! Whee! I'm too tired for this. Okay, so this is multiplication. 4 times x is going to give you 4x. You bring down this plus. The second arrow says that we have to do 4 times 2, which is 8. I'm just going to rewrite this right side because I didn't do anything with it. Automatically, I can tell this equation is always going to be true because you have the exact same thing on both sides. But let's keep pushing ourselves. To get rid of this 4x, you would do minus 4x on both sides. These two would cancel out, and then all you would have left is 8 equals 8. You know that's always true, right? And to show you one more way, I know some people are like, why'd you get rid of the 4x? It's because I felt like it. If you want to get rid of this plus 8 instead, do that. Minus 8, minus 8, they cancel out. And you still end up with the same thing on both sides, 4x equals 4x. And you're good to go. Either way, you could show that this is always true. So study hard, guys. I'm really excited to see how you do on the assessment on Monday, which is the 15th. And I hope you have a good weekend. I'm an artist. Don't hate. Take care, guys. Bye.